Okay, here's a common kind of question which comes in 3 stages, and the first time you do it, it looks very complicated, but it's often broken down for you, and I'm going to show you how to find your way through it. So we're often given an equation of 2 graphs, one's a line, one's a curve. Notice there's an unknown k, so we just treat that as a number. In part A, we're going to find at a point of intersection, we're going to show that this is true. And then it tells us a little bit more about the intersections, and we've got this to show, and then we've got to find the possible values of k. We've got to pick up the use of show that questions, okay, and we've got to pick up the key words, okay. All right, this talks about points of intersection, okay, so that means our starting point is going to be the equations of the graph. Point of intersection means we're going to do simultaneous equations with these two. All right, the words show that, okay, mean that this is going to be our end point. So we're going to want to end up with that, all right, but our starting point is going to be the 2 equations. Okay, so our solution in part A is going to be y equals, just write out the equations again, kx minus 3 and y equals x squared plus 1. Okay, I'm going to substitute one into the other. They both start y equals. So if I put the first one into the second one, or the second one into the first one, we're going to get the same thing. I'm going to slot in this x squared plus 1 in for that y there. So I'm going to get x squared plus 1, that was that y, because that's what y is according to this equation, equals kx minus 3. And then I'm going to organise this so that I'm going to work across the page so that I get as equals 0 on the other side. So I've got my x squared. I need to take this kx term away, so I'm going to get minus kx. And I need to add this 3 to make that go away to end up with 0. 1 plus 3 is plus 4. So I've got this equation, and lo and behold, I've arrived at the end point that I wanted to. Great, okay. So part A was intersections. In part B, okay, the thing to latch onto for my start point, okay, well, once again, it's a show that question, so this is my end point again. That's where I want to end up. Where's my start point? Well, it tells me there are 2 distinct points of intersection. 2 distinct points of intersection when I've just got a quadratic equation, 2 distinct points, 2 distinct roots. We know this quadratic equation in part B, our starting point, is that we have distinct points and therefore distinct roots of our quadratic. And as soon as I pick that up, the first thing I write down is b squared minus 4ac equals, no, not equals 0. Distinct roots is when that is greater than 0. Okay, and I need an a, b and a c, so I'll look at my equation, decide a, b and c. Well, a is going to be 1, b is going to be this minus k, and c is going to be this 4. So I plough ahead, b squared minus 4ac, well, it's going to be bracket squared minus 4 times bracket, and it's going to be greater than 0. Okay, my b is minus k, so minus k squared, minus 4 times a is 1, c is 4. Okay, and then minus k, when you square it, when you square minus k you get, well, k times itself would be k squared, and minus, when you square a minus number you just get the positive answer, so that minus sign just disappears when we square this. And then I've got a minus times a plus, so it's going to be minus, and 4 times 1 times 4 is 16, so k squared minus 16 is greater than 0, and lo and behold, I've reached that endpoint. Okay, and then in part C I've got to do, well, it says the keyword is hence, but that just means I follow on from where I was. I've got to find the possible values of k, and this is my starting point. I've got to use my previous answer. Okay, so this is an inequality. Okay, it's got k squared in it, so now we're using k's not x's. Okay, but that's all right. We've got k squareds in it, so this is a quadratic inequality, so we're going to use a graph. Okay, so in part C, all right, the first thing I want to know about my graph, of course, are the critical points. So the critical points, this is going to actually equal 0. I could factorise this, but this particular kind of quadratic without the middle term, I'd prefer, I think, to say k squared equals 16. I've added 16 to both sides, and then I square root, so k equals, we're taking a root, there's something to think about, we've got to be really careful. We do get 4, but we also get minus 4. There are two possible values of k, plus or minus 4. So I know my critical points. I know that it's going to be the k squared term acting like the x squared term is positive, so it's going to be a smiley one. Okay, and the 2 points where it crosses the x-axis, I know my critical points are minus 4 and 4. Okay, and I want in my inequality to be greater than 0. So we know that on the x-axis we're equal to 0, below it we're less than 0, and above it we're greater than 0. You can put y in front of all of those if you like. Okay, so where do I want to be? I want to be greater than 0. So I want these two bits of the graph. Okay, and then working horizontally, what x's do I want? Well, I want these bits of the x-axis here. I don't actually want to be on these because this is strictly greater than 0. So all I've got to do is decode this. I've got two different parts of the x-axis, so I'm going to record two different ranges. So k could be less than minus 4, or the other part of the solution is k is greater than 4. Okay, and I'm done. And that's probably one of the trickiest kinds of question at first glance that you get. When you get the hang of these questions, they're not too bad at all.